All right, so this is the first of 3 addendums to 14.6. I'm going to do 3. There'll be an example for each. So we'll call this 14.6 addendum example 1. So what I'll do is I'm going to give a spherical coordinates question and work through it all the way up until we have an iterated integral, and then we'll stop there. So here's the example. Suppose D is the solid inside x squared plus y squared equals 9, outside z equals the square root of x squared plus y squared, and above the xy plane. And what we want to do is we want to evaluate the integral over d, triple integral over d, of x squared dv. So I haven't said anything about what these things look like. So first order of business is to figure out what these things look like, because that is going to tell us how to iterate the thing, how to parameterize the d, how to give us an iterated integral. So what does d look like? So I'm going to draw a bunch of pictures as we sort this out. But first of all, I'm going to draw just a very simple picture that shows us what's up. So we have an idea what we're dealing with. So if we look at these things that were given to us, so x squared plus y squared equals 9, this right here, that's a cylinder. Radius 3, like this. So we are inside that. Second thing that's given right here, that's a cone. 45-degree angle, opens up like this. Right there. And then we are, give that some depth, and then we're above the xy plane. Now it could be helpful, so just to be clear, the D is the solid that's between these. So here's a separate picture of D without too much clutter. Imagine taking a solid cylinder and drilling a hole into it in the shape of a cone. So in here, you want to think there's like a cone-shaped hole. And D is all this stuff around here. So it wraps all the way around. D is solid, don't forget that. So if we're going to iterate this integral, we need to know basically 6 things. We need to know the range for theta, that has 2 values, the range for phi, that has 2 values, and the range for rho, and that has 2 values. So one of these is easy, one is slightly less easy, and the last one is a little bit more work. So we'll walk through these in steps. So the one that's easy to see is that theta goes 0 to 2 pi. This is because there is stuff all around the object, like all around the xy plane. So theta wraps all the way around, so that's easy to see. B. Next one's not so easy. What we need to do is we need to look at rho. Oh, sorry, phi. So let's look at another picture of this object. So let me draw the blue version again, the version on the right. So what I want you to do is put yourself at the origin. So I'll do this in, say, green. So if you put yourself at the origin, imagine looking straight up. If you look straight up, there is no D. So then you start to change your phi, and so the angle of phi goes up, which means you drop down, and you first see some D right here. There's no D until you get to here, and then there's D. And that is at phi equals pi over 4, which is the angle of the cone. And then if you keep going, there's D all the way until here. So here, D continues. And here it ends at pi over 2. So that tells us our range. It tells us that we can say thus phi goes from pi over 4 to pi over 2. That's done. And then last, C. How about rho? So again, let me redraw this thing in blue. And again, you're going to put yourself at the origin. Right here. And then what you want to do is think about taking a trip out through D. So if you could come out this way and you exit at the cylinder, you could come out this way and you exit at the cylinder, come out frontwards, you exit at the cylinder. So when we leave the origin, this is how your brain wants to think. When we leave the origin, there is D from the get-go. We are immediately in D. So D starts at rho equals 0. Now it ends at the cylinder. Now the cylinder is our x squared plus y squared equals 9. But that is not in spherical, so we need to convert it. So remember that x squared plus y squared is rho squared sine squared. So we have rho squared sine squared phi, to be specific, equals 9. If we take the square root of everything and divide by the sine, we get rho is 3 cosecant phi. So that is our outer function. That is our far function, if you like. So we can therefore say that rho goes from 0 to 3 cosecant phi. That's that. So these things, these 6 values, let me encircle them all in pink. We have the range of theta over here. We have the range of phi right here. We have the range of rho right here. That is everything. So that allows us then to write down what this integral is going to be. So finally, this integral that we want, integral over d of x squared dv. So the outer integral is the theta. The next is the phi, pi over 4, pi over 2. Next is the rho, 0, 3 cosecant phi. Then we have the x squared. The x squared, remember the x when we convert it to spherical is rho sine phi cosine theta. So that is the x. We square it. Then we have the Jacobian, rho squared sine phi. And then d rho d phi d theta. So just to clarify everything, label some things. This x squared becomes this squared. This right here is the Jacobian. And that is it. From here, it's just a matter of evaluation, not necessarily pretty, but evaluate. That's the end of that example.